So chapter 2 primarily deals with polynomials and the different things we can do with polynomials. So we're going to start today with the second most basic polynomial. First most basic would be like a linear function, right? Well, like we're past that, right? That's so algebra 1. We're going to concentrate on quadratics. Now technically we've talked about quadratics a little bit, right? We talked about the parent function y equals x squared. Okay? So what we're going to do, essentially, we're going to keep in the back of our mind our knowledge of the parent function y equals x squared and our knowledge of transformations and kind of mesh what we're going to talk about today and that together. So first of all, we all need to have an understanding that this is what a quadratic function looks like. And I feel like you've known that since what? Algebra 1 is when you started talking about quadratics. Okay? This is probably the form that you're going to see most quadratics. Okay? But we're going to work today on what's called standard form. You know it to be vertex form. Okay? So what we're going to do today is we're going to take a quadratic that looks like this, ax squared plus bx plus c, and we're going to manipulate it algebraically until it's in standard form, which is this. Does that look familiar? Now, I think in Algebra 2, you knew this as vertex form. Why would this be called vertex form? Max?
Because you can just look at it and see where the vertex is.
When you look at this, where's the vertex?
At HK.
Okay, our vertex is at HK. All right? It is nice when your quadratic is in this form because we can determine what H and K are. That's where our vertex is. A gives us a vertical stretch or shrink, so we can look at that equation and in about 30 seconds come up with a graph. Okay? That's why we've talked about all of these functions and their transformations. Okay? Now, here I have a graph of a parabola. Okay? HK is where the vertex is. All right? And then I have this dotted line right here. Why do I have this dotted line right here? Okay. Gabriel, did you say something? An asymptote? I have an issue though because I have a point. Do we typically see coordinates on the asymptotes?
You know what?
No. So maybe it could be something else. Okay, Riley?
Is it a line of symmetry?
It's a line of symmetry. Okay? We're going to call this the axis of symmetry, and it's always going to happen at x equals h. It's a vertical line that goes through the vertex. That's where the parabola has symmetry. It's always going to be the line x equals h. Okay, so whatever that x coordinate is, that's where our vertical line is going to go through.
Yeah, I was gonna.
Those grapes do look delicious. I'm slightly jealous. All right. Now, I have some fairly easy questions to answer up here. Okay? Think in your head, what does a parabola look like if A is positive? What does a parabola look like if A is negative? Okay. Nate, what's the difference between A is positive and A is negative? What does it look like on the graph?
Reflection.
Yeah, it goes up or down.
Okay, so which one opens up? Thank you for your enthusiasm. I appreciate it. Okay, so those aren't the most beautiful parabolas, but there they are. Okay, now each of these have a special feature. Okay, and it happens at the vertex. Okay, I want you to have a discussion at your pad. What is special about the vertex in this parabola? And what is special about the vertex in this parabola? What is your observation? Have a discussion.
It's like the velocity.
All right, what do you guys think up here?
You said B is positive and the vertex is negative, and then A is negative.
All right, I want your attention back up here. I just had a discussion with Pod 4. Pod 4 told me that if A is positive, the vertex is a minimum. And if A is negative, the vertex is a maximum. Brayden, is that true?
Yes.
Yes, you think so? Okay, and how do we know?
Because it's positive, there's nothing below the vertex.
Okay.
Bigger than above the vertex.
Perfect. All right. So if I gave you some sort of quadratic equation and I asked you either for a maximum or a minimum, as long as you can identify the vertex, you can answer that question. Okay? So that's something we're going to work on today as well. All right? So let's just work on how we identify that vertex form if it's not in vertex form. Please write down this problem. We need to review a method called completing the square. Don't make that noise. Yay! Completing the square! Okay. You've already done it, at least in one class. So this is somewhat of a review. A review that we probably need. It's a skill that we still need to work on. All right? But we're not starting from scratch, so that's the good news. Okay? So I will remind you that when we have to complete the square, here, let's see. The reason we have to what's called complete the square is because we want this perfect square binomial right, the square of a binomial right here, so it can be in that vertex form. Okay? Well, can I factor x squared minus 6x minus 1? You can't even factor it, right? So it's not even helpful. All right? But if we can get it to look like this, then we can identify the vertex, we can get it graphed, all of that good stuff. All right? So what we're going to do is we're going to take x squared minus 6x and we're going to add a number to it so that we can write the square of a binomial. But can I just add in a number to an equation?
Let's try.
I can just add in a number and change the entire value. Okay, so we could add it to this side, right? And then that would balance out. What would be another option that would be the same as just adding it over to the left side?
Subtract it.
Subtracting it from the same side. So since we don't have this side equal to 0, we're going to go ahead and subtract it from the same side. Okay, that way we just keep everything on the right side since we have a function. Okay? If you want to add it to the left side, and then move it back over, that's fine. All right, but since we're just working with an equation that's not set equal to 0, we have like that y over there. We're just going to do it all to the same side. Okay? So let me remind you what we need to do. This is b. We take b over 2, and we square it, and that's what goes right there.
What?
We take b, divide it by 2, and then square it, and that is our mystery number. Okay, so if b is -6, b over 2 would be -3. When we square -3, we get
9.
Thank you, Mom. So we're going to add 9 and subtract 9. So technically we're adding 0. So our equation isn't changing. Okay. Now watch what happens. X squared minus 6x plus 9. That factors to x minus 3 times x minus 3, doesn't it? We did that on purpose, right? So we can write this as x minus 3, the quantity squared, minus 10. Isn't that great?
Yeah.
And that didn't take us a whole lot of work. I mean, it was like a 2-step problem right there. I can handle that. Okay, now let's talk about what we can do with it. First of all, are there any questions about the completing the square process? We'll do it again.
I'm just lost.
Okay, tell me where.
Like, how'd you get that bottom answer?
This one?
Yeah.
Okay, so if we take x squared minus 6x plus 9, that factors to x minus 3 times x minus 3. Do you agree?
Yes.
Okay, so we can write x minus 3 times x minus 3 as x minus 3 squared. And then we have this minus 1 minus 9 that we can combine to the 10. Okay, thank you for being brave and asking that question. I appreciate that. Other questions?
So we can just take b and divide by 2, like, can we do that to any other variable?
Well, we're doing that strategically because that's how we get that perfect square trinomial. Okay? Since we want this x minus h squared, we do that to get the mystery number that will force us to be able to factor like that.
This is just a thing we can do.
You did this last year.
But, Gabe,
I was out.
we added 9 and subtracted 9. So did we change anything?
No.
No, we added 0, which is why it's okay. It's kind of like multiplying by 5 over 5, right? That's like 1. We didn't change it. We've added 0. So nothing has changed. It just looks different.
What's your decision? Oh, yeah.
But looks can be deceiving. Yes, I agree. Okay, so let's talk about what we know now. The vertex. Austin, where's our vertex?
3 negative 10.
Let's talk about why. We have a shift, right 3, down 10. So our 0, 0 vertex gets shifted right 3, down 10. Okay, so there's our parabola. Guy, you're very excited. Where is our axis of symmetry?
It would be on x equals 3.
Thank you for describing it as a line. X equals 3 is that vertical line. Okay. Questions here? See how nice it is to have it in that form? Right? We can easily get that graph, identify the vertex. We can also easily find its x-intercept.
Wait, is it like this, or is it like curved?
It's curved. can't tell that from the picture.
Well,
I
like
have
from
up
back, I
here.
can't see the bottom of it. Like from back here, I can't. There it is.
Okay. Your homework is also going to ask you for x-intercepts. Okay. X-intercepts. Let's think about algebraically what that means. X-intercepts. Algebraically means what, Kinley? Okay. So algebraically, like what would we plug in? When y equals 0, Emily, is that right? Think so? Okay. When y equals 0, so let's do that. Remember, originally we couldn't even factor our quadratic, that x squared minus 6x plus 1 or minus what, I don't even know what it was anymore. Okay? We couldn't factor it, but here we can solve for our x-intercepts, right? We can add this 10 over. Next step would be to square root both sides to get rid of that square. Now I need to remind you that when we square root both sides to solve an equation, we have a plus or minus radical whatever the number is. So there needs to be a plus or minus radical 10. Remember, there's two answers here. It's hitting twice. Then we can add that 3 over. So 3 plus or minus radical 10 would be the two places that we have x-intercepts. 3 plus radical 10, 3 minus radical 10. Okay, what do you think? Right? And isn't that way more efficient than doing the quadratic formula? Quadratic formula, it's very straightforward, but it's very tedious, isn't it? Okay? We need to practice completing the square root more, don't we? Yeah. Okay? Let me make a comment. And maybe you remember this from last year. But we can only complete the square if the leading coefficient, if A is 1. Chances of it always being 1. Please write down this right here. And I'll read it to you. Mrs. Holman went to the batting cages to hit some softballs. While she was there, she had many great hits and some not so great. One, in fact, followed the equation of f of x equals negative 16x squared plus 48x plus 2.5, where x represents the time in seconds and f of x represents the height of the ball in feet. What is the maximum height of Mrs. Holman's hit? Okay, take a minute to just process that mentally as you're still writing down the equation. Maybe write down maximum question mark so that you know what we're about to find when you look back at your notes. Okay? And then go ahead and turn to your neighbor and tell them, how do we determine what the maximum is? Mary Kate, what do we need to find?
The vertex.
The vertex. Mary Kate says the vertex. Max, would you agree?
Yeah.
Okay, thank you, Max. Okay, well, in order to determine the vertex, we're going to need to, oh darn, complete the square. Is my leading coefficient 1?
No.
Nope. Mrs. Holman, you told us we couldn't complete the square. You're right. What is our leading coefficient?
Negative.
Negative 16. So what we're going to have to do is we're going to have to factor out negative 16 to force our leading coefficient to be 1. Factor out the leading coefficient. Now, when we factor out negative 16 from 48, negative 3x. Okay, check yourself. When you distribute it back, negative 16 times negative 3x is positive 48x. Okay? Okay, you're panicking about that 2.5. Don't. It's going to be okay. First of all, we need a mystery number, right? We need a mystery number. Do you notice how I ended my parentheses?
Yeah.
Okay, that negative 16 doesn't need to affect the k. So I'm going to end my parentheses, which means I'm done factoring, and then I'm going to add the 2.5 after it and subtract a mystery number. That way you don't have to worry about factoring a negative 16 out of 2.5. It's not necessary, okay?
Why is it adding the first mystery number and then subtracting the second one?
Because we want to add 0.
I thought that meant you have to subtract it.
Well, we're on the same side. So if I add 5 and subtract 5, boom, it's 0. If I add 10 and subtract 10, it's 0. What you did probably last year was subtract 10 from the right side and subtract 10 from the left side, and then that balances.
Yeah.
Do you see what I mean?
Yeah.
Okay. So, b over 2 would be negative 3/2, right? And b over 2 squared, negative 3/2 squared, would be positive 9/4. Now, did I really add in 9/4? Why not, Riley?
Because you are subtracting it to 60.
So if I just put 9/4 right here, it will be balanced?
Yeah.
Eddie, you seem unsure. You're just taking it all in.
Yep.
Everyone's okay with just 9/4. Gabe, you're not?
Since it's on the outside, it's not going to affect the right-hand side.
Okay.
So it's not going to make sense.
It's not going to make 0. Kaya, add on to, Gabe says it's not going to make 0.
You'd have to multiply it by negative 16.
9/4 is being multiplied to negative 16.
That's big.
So really we're adding 36,
Whatever that is.
negative 36.
How'd you do that?
Okay. Do you agree that this 9/4 is being multiplied to the negative 16 because it's on the outside of the parentheses? So negative 16 times 9/4 will, 16 divided by 4 is 4 times 9 is 36. So negative 16 times 9/4 is negative 36.
But you didn't do that to the rest of the problems.
Right, because this is out here, which is why we have to put negative 36 here. If I were to distribute that negative 16 through and combine like terms, we need to get back to up here. So since this 9/4 that I wrote in is being multiplied to this coefficient that we factored out, that's the number that we're really adding, so we have to subtract it. Okay? Also notice how this number is negative, so we have to subtract a negative number to balance it out. Okay? Okay. Okay. I'll also give you another piece of advice over here. Our b over 2 was 3, and then we squared it to get 9. It's always going to factor to x minus b over 2, that quantity squared. So over here when you're panicking, like I don't know what that is supposed to factor to. It's going to factor to x minus 3 halves the quantity squared. Okay. Let's talk about what this means. Okay. This parabola that opens down has a vertex of 3 halves, 38.5. And 3 halves, since this is a decimal, we all know that 3 halves means 1.5. Okay? Remember, up in my problem, x represented seconds, and f of x represented height in feet. So, at 1.5 seconds, the ball is 38.5 feet in the air. Not a great hit. Basically went like straight up in front of me, right? Okay, I popped it up to the picture. Really high. After 1.5 seconds, the ball reaches a maximum height of 38.5 feet, and then it'll start to fall. Yes.
So then the 16 doesn't have to do negative 16.
The negative 16, so that's just telling us we're upside down with our parabola and it's super skinny, right? Because we have that vertical stretch. This is not one that I would make you graph, okay? But that's just telling us that we are looking for the vertex because it's going to be the maximum since it's negative. Okay. Now, if I gave you like a leading coefficient that was like 2 or 3, that's something that I would expect you to still be able to graph. Like you could do a vertical stretch of 2 or 3. Okay. How about I give you a couple minutes? Oh, actually we do have one more example. I forgot about that. Okay. Last questions on this before we do our last example. Okay. Are you going to have to practice completing the square with the leading coefficient not 1? Yeah, you are. Okay. Go ahead and write down parabola with a vertex of negative 411. So write down vertex of negative 411, and it passes through the point negative 615. They've told us it's a parabola, right? Yeah, they told us it's a parabola, which means we know that y equals a times x minus h squared plus k. Would you agree? Okay, so you're saying can't we just like put in the vertex, right? We know the vertex. Yeah. Our vertex is negative 4, 11. So we have x plus 4 squared plus 11. All right, now A, we need to determine A in the next 2 minutes.
Can we plug in the points? Negative 6 and 15.
Okay, we know negative 6, 15 has to satisfy this equation. So we can plug 15 in for y, negative 6 in for x, and solve for what A is. Okay, so I'm going to subtract 11 over. Negative 6 plus 4 is 2, squared is 4. Well, that's kind of boring, huh? A is 1. So y equals 1 times x plus 4, the quantity squared, plus 11. Max, you have a question? Okay. You need to do your homework tonight because I'm going to give you a 2-question quiz tomorrow. Low pressure, okay? Yes. Oh, thank you so much. I have them right here. Gold sheets. Make sure you have your calculator tomorrow because we're going to do some exploration with polynomials. Both tomorrow and Tuesday. How do you think? Can I say anything here? Well, I'm coming. There you go. Oh, you just put them away so fast. Everyone got a gold sheet? Pod 5? Sometimes I forget you in the middle there. Okay.
So where's me at?
Can we just email?